Hello everyone, welcome to my channel Coding Together. My name is Vikas Ocha. Today we will see another lead code problem, that is maximum binary tree. It's a medium level question and it's a very popular question, as you can see from the likes. So let's read the problem statement. You are given an integer array nums with no duplicates. A maximum binary tree can be built recursively from nums using the following algorithm. Create a root node whose value is the maximum value in the nums, and recursively build the left subtree on the subarray prefix to the left of the maximum value, and recursively build the right subtree on the subarray suffix to the right of the maximum value. Return the maximum binary tree built from the nums. So let's see an example, that is nums 321605, and we have to construct a maximum binary tree. First, we will calculate the maximum of the array, that is element 6. So 6 will be the root node of the tree, and the sub array prefix of this maximum value, that is 6, or on the left sub array on the left side of this maximum value, that is 6, will go as a left subtree for this root node, and the sub array suffix of this maximum value, or on the right side of this maximum value, will go as a right subtree of this root node. Now on for the left subtree, right, or the sub array 3 to 1, we will again calculate the maximum element, that is 3. So we will put 3 as a root node, and as on the left side there are no elements, so the left child of 3 will be null, and on the right side we have a array 2 comma 1. So we will put 2 comma 1 as a right subtree. Now again we will choose the maximum of 2 comma 1, that is 2. So 2 will be the root node, and 1 is on the right side of the 2, so 1 will act as a right child of 2. And for 0 comma 5, 5 is the root node, and 0 is on the left side of 5, so 0 will be the left child of root node 5. So let's see how we can solve this problem. So I've taken the same example with an array 321605. So we will maintain two variables, I and j, I and j as the start and the end of the array, right? In which we have to find the maximum element. So I will point at 0. So in the start, at the start, I will point at the index 0, and j will point at the index 5, right? And the maximum element over the range from 0 to 5 is at index 3. So maximum is at index 3, that is element 6. So we will create a node with a value 6, right? We will create a root node with value 6. So we have first calculated the maximum, that is element 6, over the range from 0 to 5. Now we will iterate, we will recursively go on the left side. So for the left side, we will go from 0, that is the current I, till max minus 1. So max index is 3, 3 minus 1 is 2. On the right side, we will go from max plus 1. So max index is 3, 3 plus 1, that is 4. 4 till the current j, that is 5. For the left subtree, our I is pointing to index 0 and j is pointing to index 2. Now again we will calculate the maximum, but now the maximum we have to calculate over the range from 0 to 2. So the maximum is element 3 at index 0. We will create a root node with element 3, because the maximum is 3 at index 0. So again we will go on the left side with a range that is from 0, that is I, and max minus 1. So max is pointing to index 0, so 0 minus 1, that is minus 1. So as I has become greater than j, so we will return null, right? And for the right hand side, we will go from max index plus 1, that is 0 plus 1, that is 1, till the current j, that is 2, right? So now I is pointing to 1 and j is pointing to 2. Now again we will calculate the max over the range 1 to 2. So maximum
will is at the index 1. So maximum index is 1, that is element 2. So we'll create a node with element 2. Or on the left hand side, right? On the left hand side, we will go from I, that is 1, comma, max index minus 1. So max index is 1, 1 minus 1 is 0. So again, I has become greater than j, so we will return null. Or on the left side, we will go from max index plus 1, that is 2, and the current j, that is 2. Now I is pointing to 2 and j is pointing to 2. That is the same index. So now the max is at index 2 and the value is 1. So we'll create a node with value 1 and we will go on the left side. So for the left side, we will have our I, that is 2, and j will change to max minus 1. So max is at index 2, 2 minus 1, that is 1. Now again, I has become greater than j, so we'll return null. Similarly, for the right hand side, we will go with I change to max plus 1. So 2 plus 1, that is 3, and the j as it is, so 3 comma 2. Now again, I has become greater than j, so we'll return null. So we'll return from here, we'll return. Now on the right hand side, we are have our range I and j, that is 4 comma 5. So our I is pointing to 4 and j is pointing to 5. Now we will calculate the maximum over this range. So maximum is at index 5, that is element 5. So we'll create a node with value 5, which is at index 5, and we will, so the max index is at 5. Now we will go on the left side. So for the left side, we will go with the I as it is, that is 4, and j will change to max index minus 1. So it will be 4. So on the right side, we will go max index plus 1 as I and j as it is. So now I has become greater than 5, so we'll return null. So at index 0, we have I pointing to 4 and j pointing to 4. So our max index is at 4 and the element is 0. So we'll create a node. And on the left side, we will go with a range I, that is pointing, that will be the same 4 and max index minus 1. So max index is 4, 4 minus 1, that is 3. So now I has become greater than 3, so we'll return null. And for the right, it will be 5 comma 4, and as I has become greater than j, so it will return null. So we'll return from here, and we'll return from the node 5 and return finally from the root node 6, and we'll return the root node 6 as an answer.
So let's see the code part for it. I have coded this solution in the Java language. So I've created a class solution and I've created a public method that is construct maximum binary tree, which takes input as the nums array and returns a tree node, the root node of the finally constructed maximum binary tree. And I have created two auxiliary methods. One, construct maximum binary tree. Two, recursively call the left and the right subtree over the range int I and int j. I've created another method that is maxLE that gives the index of the maximum element. So first we will start over the range from 0 to nums.length minus 1 from the start and the end of the array. We'll check if I, or the start end and the end index of the array over which we have to work. So if the start is greater than j, I is greater than j, will return null. We'll find the index of the maximum element. So we'll call the maximum element method for the array over the with the start index, that is I, and the end index, that is j. So in the method maxLE, we are finding the index of the maximum element. So we are starting from the index I and we are going till the index j. So first we are setting index as I, that is the start index
and then we are going in the for loop with the start equal to I and start less than equal to j, and if the element at the index is smaller than the element at the index start, we are changing the index to the start. It means the element is greater than the current index element. And finally, once the for loop is completed, we'll return the index of the maximum element. Then now we have the maximum element over the range I comma j. We'll create a root node with the maximum element, and the root dot left will be again recursively will call the same method construct maximum binary tree with the array as the input array I as it is as the current starting index, but the last index or the end index will change to the index of the maximum element minus 1, because as we saw we found the maximum element 6. On the left side we iterated from 0 to 2, and on the right side we iterated from 4 to 5, right? So on the left subtree was the sub array on the left side of the maximum element, and right subtree was the right sub array on the right side of the maximum element, right? So we first found the max index, we created the root node, and for the left part, left child of the root node, will again recursively call the construct maximum binary tree with this array starting index I as it is, and end index will be max index minus 1. So just the index just before the index of the maximum element, and the right part of the root or the right subtree of the root again we will call the construct maximum binary tree with the same array, and but this time the start index will change to max index plus 1. So just the index just after the index of the maximum element, and the end index will remain as it is, and finally when the left and right is completed we'll return the root. So let's run this solution. So yeah, test cases are accepted, so it means this solution is working fine. So let's talk about the space and time complexity. As we know, the traversal of the tree takes big O of n time complexity, but at each node we are calculating the maximum element for a range of array. To calculate the maximum element, we might run in a worst case big O of n time complexity. So the total time complexity is big O of n square, and the space complexity will be big O of n, as in the worst case the height of the tree can grow up to n, where n is the size of the array, right? So in the worst case the tree can be a skew tree. So as we know that the tree maintains the stack, implicit stack, so it can be the worst case in the stack it has all the elements for a skew tree, or the left sided, all the elements on the left side of the tree, or all the elements on the right side of the tree. So I hope you enjoyed watching this video. If you like this video, please share and subscribe. Thanks for watching. Bye.